Okay, so this would be the next round of notes for electricity. We're going to be talking about voltage and current. We've talked about forces, we talked about charge. And so where we're headed now is what happens when the charges start moving and how do they start moving. And so we start off with this cute little charge here, and it doesn't really matter if it's a positive charge or negative charge. And every charge is surrounded by a field. And that field can exert those Coulomb forces on other charges. So we have the charge, we have a field around it, the field exerts forces. Those forces cause the charges to move. And one of the things that we know that when something moves, it also needs energy to move. And so you're going to have a thing called a potential difference that's going to provide that energy to move the charge. And then now we have the moving charges, and when you have moving charges, you get the end result that we see and we use, and that would be current. You can't really see the current, but you can see the effects of the current. And when we're dealing with currents and voltages and circuits, we talk about something called electric potential. And that's really the physics words for it. What you'll hear about it is, in just regular conversation, is voltage. And they are the same thing, basically. It's the idea that it requires energy for currents to move, and a difference in voltage or the potential difference gives it that energy. And so, once again, it starts off with that electric field around the charge, and it's measured in volts. So you've got the unit for voltage is volts. The moving charges create a current. Same idea. Seen that a couple times. It's done because the forces cause the charge to move, and the voltage difference gives it energy. So kind of repeating things over and over again, but you get the idea that those things have to be there to get that current. And when we're talking about currents, we will have to talk about the direction that currents move. You'll see this referred to as conventional currents. And it will seem backwards to you because we've been telling you that it's the electrons that are doing this, but what happened is back in the times of Benjamin Franklin, everything was observational, and so they didn't really know what was moving. It was charge that was moving, so they said, hey, I'll put a positive charge here. And if I do that, we'll see which way it goes. And sure enough, it would go away from the positive end of the battery and towards the negative end. That's what would happen. It should repel and be attracted. And so that's what they decided was the direction. So we're going to say it's going to flow from positive to negative. And you will see conventional currents. And talking about currents, you often hear AC and DC. And they are two different types of currents. They both light light bulbs, they both do the things that we need to have happen, and they are different in the way that they are carried. DC is direct current, it flows in one direction. You can think of it like water going through pipes. It's just going to keep flowing. Usually you have a battery, your phones are DC. Anything else that you plug a battery into is DC, so flashlights, phones, any battery operated thing. The AC is alternating current, and what that's doing is it's changing directions back and forth constantly, so it's kind of vibrating. So while DC will just go around, AC ends up going back and forth, back and forth, back and forth. And it's actually done, the wall plugs are AC, and it's done that way because it travels farther. So it can come from the power plant to your house. It just travels better as AC current. And where we have the AC current, but our phones are DC and we have to charge them up, that's when you use those little transformer boxes, those little seemingly large objects you plug into the wall. Some of them are bigger than your phones. For the computers, for your phones, for things like that, they're big and heavy. Those are the transformers that change it from AC to DC. The AC circuits count on that current changing 60 times a second, going from positive to negative or on and off, just back and forth and back and forth. The lights in the ceiling flicker. You don't see it. but they do that 60 times a second because it's faster than your eyes can see. So that's current stuff. Where it comes from, remember, it starts off with that charge, and then the charge has to move. Once you get current, you can do things with that current, and we will start working with circuits soon. So you'll start to see how to light the light bulbs, how to change the amount of current and the amount of voltage in a circuit, and how that's going to work. For those of you anticipating a math problem, I'm sorry to disappoint you, there is not one. So this is it for the notes, short and sweet. So you guys have a great evening.